Hello friends, welcome to Shiksharthi. In this video, we shall be discussing the basics and the concepts of the mensuration aspect of circles. So let's start. Now if you have gone through my first video wherein we talked about quite many aspects of finding out the circumference of the circle or the area of the circle or the circumference of a semicircle or the area of a semicircle, in this session we will focus on some other geometrical figures along with the circles and see as to how to find out the area. Okay, so starting off with, so now this is a circle, and if I have to find out the area of the segment, as discussed, how is the segment formed? Segment is formed with the help of, I'll just come back. So let us say this is O, this is A, this is B, and this is C. So what is the segment area? The segment area is this. Now the area enclosed between the chord and the arc forming the same chord. Now that arc could be the major arc or could be the minor arc. So here, in this case, we are basically talking about how to find out the area of the minor segment. So can I say area, now AR I am using for area. So can I say that the area of the segment, and I'm talking about the minor segment, I'm using this as MIS. Now MIS refers to area of the minor segment. And here the minor segment we are talking about is ACB. Can I say this is nothing but the area of the sector? Now which sector are we talking about? We are talking about sector OACB minus the area of, let's say, the area of the triangle. So the triangle here we are referring to is OAB. And this we are subtracting. So the area of this minor segment, which is ACB, is equal to area of the sector, which is OACB, and from there I am subtracting the area of the triangle OAB. So before we go ahead, now if I drop a perpendicular from here, and I know that both are nothing but the radius R, so let's say this is given to you. In that case, can I calculate the length of the segment, the length of the chord? I can definitely calculate the length of the chord, but if the height is given to me, this height. Okay, now if I extend this point further, it joins C. So by the side of this, or here I'll write down. Now can I say OA is equal to OB is equal to OC, which is nothing but the radius of the circle, and which in this case we have taken it as R. Right? Okay. Now here, so which are the topics that we are going to use to find out this area? And as suggested earlier also in my other videos, please take theorems or the proofs as questions first. Prove them first before you start solving the questions. And that always helps you to remember the formula which you are supposed to use without even remembering the formula. Right? And it is rather interesting. So now we'll approach this in a fantastic manner. Now what is the fun part here? Have we done trigonometry? Yes. Do we know what is the area of a triangle in terms of geometry? Yes. Half into base into height. So now if I have to calculate the area of the segment, and do we know the area of the how to calculate the area of the sector? Yes, that also we know it, which is just like saying pi r square. And here I am taking this as theta and this as theta. So can I say, okay, coming back to this in few minutes. So can I say now that the area of the sector OACB will be what? Pi r square into 2 theta upon 360 degrees. This is the area of the sector formed. And what is the angle this minor arc subtends? The minor arc subtends an angle of 2 theta at the center. Now if I am dropping a perpendicular from the center of a circle onto a chord, it should divide the chord into two equal parts, and this point I am taking it as D. So can we say that AD is equal to DB? Use some concepts of geometry to prove this, which is using either SAS or SSS or any other criteria for congruency is what you can use. Why I suggested SAS is because of the fact that side, angle, side, side, angle, side, this is a common side. So you'll be able to say that this triangle, which is triangle OAD, is congruent to triangle OBD. Okay, once you're able to say this, now can you calculate the height here? Of course you can calculate the height, but if I want to do it in terms of trigonometry, I know the perpendicular and I want to find out the height, which is this. So can I look it like this, that cos theta is equal to base upon hypotenuse. So can I say, I'm just writing it down here, can I say cos theta is equal to base, which is OD, upon hypotenuse, which is OA, and from here I'll get the value of OD as OA cos theta. Can we say this? Of course we can. Now can I calculate the area of this triangle, which is just like saying half into base into height? So I have the height part here, but I don't have the base. So in order to calculate the base, I can say sine theta is equal to perpendicular upon hypotenuse. So we'll say that sine theta is equal to perpendicular, which is AD, upon hypotenuse, which is OA. So from here we'll get the base, which is AD, which is nothing but OA sine theta, and we know that OA is nothing but, what is OA here? OA is nothing but the radius, as we already know here. So now what is the area of the triangle OAB? This is nothing but, so minus half into base. What is the base length? Twice of AD, which you will say as this is nothing but twice of R sine theta, into height. Now height is how much? R cos theta. Yeah, I'm just shifting this side so that you're able to see this in one go. So coming back again, now if I have to calculate the area of the sector is nothing but pi r square into 2 theta degrees divided by 360 degrees. From here we are supposed to subtract the area of the triangle, which is half into base. Base is how much? AB is twice of AD. So you will say that this is nothing but 2 into r sine theta into height, which is r cos theta. So from here finally we get, what do we get finally? We get pi r square into 2 theta minus, now I am taking half as common here, half r square 2 sine theta cos theta, which can be written as sine 2 theta. I hope you are aware of the fact. If you aren't, you can just understand it from here. 2 sine theta into cos theta is equal to sine 2 theta, which I have already done it in my videos. Okay, so can I write it like this? Of course. Now once I have written this, now I can take r square as common here. Now when I have taken r square as common, what do I do further? I mean, whatever you wish to do. So now if you have taken r square as common, so now you can say this is pi theta degrees divided by 180 degrees minus half into sine 2 theta. You can use this as a standard formula for finding out the segment area. Next thing which I am going to discuss now is, which is equally important. So we did not merely discuss the segment area here. We even talked about a property which says that from the center, if I am dropping a perpendicular onto a chord, the chord gets bisected. The chord gets bisected is what we have already discussed here. Okay. Now if I take a circle and I circumscribe the circle. Now when I circumscribe the circle means what? From all the ends it should be peripherized by a figure. and here the figure that I am taking is a square. So how many tangents have I drawn to the circle? I have drawn 4 tangents, such that all the 4 tangents are equal to each other. So from an external point, you can, now from this point, if I say how many tangents can you draw onto a circle, you will draw 2 tangents from any point, and both of these would be equal. So we know that AC is equal to BC. This has nothing to do whether this figure is a square or not. And if I drop from another point, let's say D, if I'm dropping another 2 tangents onto the same circle, so then I'll be able to say that DC is equal to BD. Using which property? Using the property of congruency. I mean, you could have always, and this I have discussed it in my geometry videos as well. You can go through this. Now, this is something which we already know. Now, if I put an equal to sign in between, the resulting figure that I get here is a square. Okay. Now, what I want to find out here is, what is this area? The area enclosed between the square and the circle is what I wish to find out. And this is very important, because the same concept will be used for complex figures or with complex figures also. And I'll tell you where. Okay. Now all I need to know here is, what do I need to know here? Either the radius of the circle should be told to me, or the side of the square. So let's say if somebody tells me that the radius of the circle is r, in that case the side of the square becomes 2r. Or if somebody gives me the side of the square, I'll be able to find out the radius of the circle, which will be half of it. Okay, once I know this, all I need to apply here is, what is, so now the area enclosed. The area enclosed is nothing but the area of the square ABCD minus the area of the circle, right? So this area enclosed will be nothing but, what is the area of a square? Side into side. How much is the side? 2r into 2r, which is 4r square, minus the area of the circle, which is pi r square. So from here you get the formula as r square times of 4 minus pi. This is very, very important. Now the next figure which I am going to draw is more or less a similar kind of a figure, but slightly different. Now, is ABCD a square? No. If you remember my videos on geometry, you should not be guided by the appearance of the figure. I mean, unless somebody tells you that this is a square, till then you cannot assume it to be a square. So I'll take a generic discussion here, and what I'm doing for the sake of discussing here is, now if somebody tells me that let's say I'm taking a point here as D, E, let me take it as E, and some point here as F. Now if somebody tells me that this leaf-like structure is bisected, either this should be told in writing, or it should be given to me as arc AEC is equal to arc AFC, which is just like saying the line segment AC bisects this figure, this leaf-like figure. And then why should I assume it is a square? Let me take this angle as theta, and you will see that the concept now which I am going to use here, and what I mean, before I talk about what am I going to do, let me find out the area of this leaf-like structure. Given that this angle is theta, it is only when theta becomes equal to 90 degrees, then only, and then I need to tell that AB, I mean whether AB is equal to AD or not, which is just like extension to this. So when I am saying that these two arcs are equal, I mean this arc is equal to this arc, am I given to understand that AB will be equal to AD? Okay, going further and using the same concept as we had used here. So if I have to find out the area of this leaf-like structure, what am I expected to do? Let us try and find that out. So before we go ahead, can I say that first I need to find out the area of this sector? Which sector? I am talking about ADCF. And from there, if I subtract the area of the triangle ADC, and now since I know that this length is equal to this length, in that case all these lengths I am assuming it to be as A. So this figure becomes what? A square. Does it become a square? Not necessarily true. It will be a rhombus. The rhombus becomes a square only when we say that this theta becomes equal to 90 degrees. Okay. Now going further from here, so can I use the concept that we had used here? Yes. So I am supposed to find out this entire leaf area. But in that case, let me first find out the area of half of the leaf, which is just like saying if I have to find out the area of AFC, and I am taking one more point here which lies on the line itself. So let's say I want to find out the area of AFCGA. That means I am basically enclosing this area. So this area will be equal to the area of the sector. Now which sector am I talking about? I am talking about the sector ADCFA. And from here I subtract the area of the triangle. And which triangle am I talking about? I am talking about the triangle ADC. Okay, let me take this discussion here. Okay, now if I am taking this and I am supposed to find out the area, which is the area of half of the leaf, which is just like saying area of the sector, this. So what was the area of the sector? So we know that the area of the sector is pi r square. What is the angle here? Theta divided by 360 degrees. This becomes the area of the sector, and from here I need to subtract. So now this r square becomes A. From here I need to subtract the area of this triangle, and we know now from here I can say that the area of the triangle OAB is nothing but half r square into the angle between it. Half r square into the angle. Which angle? The angle between these two sides. So it is just like saying half into the product of the sides into sine of the angle between the two sides. So which in this case becomes half of a square sine theta. Right? And now when I want to find out the entire area, so once I am able to get this area, which I have already got, and I know that this line bisects the area, so we will be able to say that the area of the leaf, which leaf are we talking about? AECFA. Is twice of this. So when we are saying twice of this, we are taking a square as common. Now theta degrees divided by 360 degrees minus half of a square sine theta. Okay, here it will be pi times of it. So this you can use it as a standard formula. So even if you forget it, you can derive it. I hope we have discussed quite many things here. The last thing which you can take it as a take home from here would be if I take two circles, let us say these are two circles, such that both the circles intersect each other at the center points. Meaning thereby, this is the center point of this circle and this is the center point of this circle. Let's take this as O1, let's take this as O2. And the radius of both the circles, radius is given as R. And now I ask you to find out the area of this leaf. Can you find it out with the help of the discussion that I have done here? As I told you also that these concepts are very important because we'll be using it at different places. At the same time, if I give you a figure like this, so these are all take home, these are all assignments, the answers of which you can put it in the comment section. Now you are supposed to find out this area. So let's say this is A, this is B, this is C, this is D, and this is E, F, G, H. And it is given to you that these are 90 degrees. And they have already given to you that EF is equal to B, let's say EH, which makes it a square. They have already given this thing to you, and you can take it as this is given to you as 2A. And one more thing that you need to know here is all these are equal. Even if they would not have been equal, still we can do it, but all of these are equal. This is given in the question. And what are you supposed to find out? You're supposed to find out the resultant area. Next, I can give you 3 circles of equal radius such that they intersect with each other. I am giving you 3 circles of equal radius such that they intersect with each other. And then I can ask you to find out the common area. This is what I can give to you. But this becomes slightly difficult because here what is the common area to all the 3 circles? And what has been given to you? They go through there, they intersect. This intersects with this is just like extension to this. So maybe if I can say that the third circle passes through like this, but then this point of intersection should pass through the center of this circle. So it is just like saying this is O1, this is O2, and this is O3. Last that I want to give you here is, let us say there are 3 circles of equal radius which are tangentially touching each other. They are touching each other tangentially. And then you have to find out this area. A kind of, almost a kind of this, though these are not touching tangentially each other, such that their radiuses are equal to each other. The radius of all the 3 circles here is R, and same the radius of all the 3 circles here is R. This you can take it as a take home, and you can apply most of the concepts that we have discussed here are applicable to these questions. If you feel that this session is really helpful and it takes your learning to the next level, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do videos on some specific topics, don't hesitate and put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.